Hello, this is Phil Adams. I'm the Chief Technical Officer for Electrolyzed Innovations. I'm also the inventor of Ion Dispersion Technology. And what I'm going to present is just a few slides that are going to give you the basic science of ion dispersion technology and our ID water. So let's get started. One of the things I'm always asked is what makes ID water different or better than regular tap water or soft water or demineralized water? And my answer is that ID water uses the physical properties of water to make products safer, greener, and faster acting. So what do I mean by physical properties? Well, let me give you a couple examples. If we had a container of water, that water really in that container doesn't really have a lot of work power. Certainly we can dilute something with it, but other than that, it really doesn't really have a lot of work power. Now, if we're able to take that water and compress it, then what we can do, that water can actually either push or lift hundreds, if not thousands of times its weight. And that's the basis for hydraulics. Another physical property of water is that if we can get water flowing, and if we can get that water flowing over a wheel, we can get that wheel turning fast enough, we can actually create electricity. And that's the basis for hydroelectric power. Now, ID water uses physical properties, but on a molecular level. And we'll talk about that here shortly. But unlike traditional formulations, where they're using water strictly to dilute the chemicals that do the work, our ID products are actually, the water's actually doing the work. So this allows our products to use a lot less chemicals or be able to eliminate chemicals altogether. So let's talk about our products and how the technology works. One of the things let's start with is just water. Well, we know water is an excellent cleaning solution. And who hasn't taken fabric under a faucet and worked out a stain with your fingers? And who hasn't used hot water and know that hot water is actually better at removing that stain and faster at removing that stain than cold water? Well, why is hot water better than cold water at removing that stain? Well, we know water is H2O, the H2O molecule. What we may not know is that the H2O molecule just by itself doesn't exist. The H2O molecule wants to bond to itself, and it keeps bonding and bonding and bonding to form these very, very large shapes in which we call water clusters. Now, at the bottom of the slide are some illustrations of water clusters. We have a 20 molecule water cluster. We have a 220 water molecule cluster. But in reality, it could be 2,200, it could be 22,000, it could be 2 million. These water clusters can get very, very large in size. What we do know about these water clusters is that they spin. And the larger the water clusters, the slower that it spins. So when we heat up water, what's happening is that these water clusters are breaking up into smaller clusters. And these smaller clusters, as we talked about, spin faster, so they create more work power. Well, ID water technology breaks these water clusters up into even smaller water clusters, much, much smaller water clusters than even the hottest of water. And this creates tremendous spin velocity in our water that creates tremendous work power. So how do we do this? Well, we've developed and patented a very unique filter media. And as we pass water through this filter media, it imparts a very strong electrical charge to the water. And as a result, what we see is that water coming out of, say, my lab, in this case, up on the upper left-hand side, is a water coming out that has a pH of 7. After it goes through our filter media, it comes out extremely alkaline, in this case a pH of 11.5. But if we slow the flow properties down and give it longer contact, we could probably even get a much more alkaline water, probably in the range of 13. Also, water coming out of my laboratory has about a positive electrical charge to it, in this case 185. After it goes through our ID filtered media, you can see that it's now changed to a negative 239. What's happened here is that we've now changed the electrical energy to over 400 millivolts, a tremendous change in electrical current. So why is that important? Well, number one, the higher the pH equals the smaller the water clusters. As we spoke, the smaller the water clusters, the faster they spin, so they provide more scrubbing and more work power. In addition, when we change water from a positive electrical charge to a negative electrical charge, it produces a surfactant effect. And the surfactant effects eliminate surface tension and enables the ID water to penetrate into the deepest and the smallest of cracks, crevices, and pores. So how does this apply to our products? Well, let's take our ice machine cleaner, for example. Competitive ice machine cleaners are high concentrations of phosphoric, muriatic, or other strong acids. And they're designed that way because the strong acid is used to dissolve all of the scale off the part. Now, if you've had any experience with acids, you know that number one, they're dangerous, they're difficult to handle, and they require a lot of safety protection to use. With our ID ice machine cleaner, it's not designed to remove all of the scale. Here on the right-hand side is a microscopic picture of water scale. And as we know, water scale is deposited over time, so it's very, very porous. So using the ID water's extremely small water clusters, coupled with very little or no surface tension, our product, our ID ice machine cleaner, can penetrate through the pores into the scale. This allows the ice machine cleaner to attack only the bonds that hold the scale to the surface. So unlike other ice machine cleaners where they're dissolving all of the scale off all of the part, you'll see when you use our ice machine cleaner that our scale, the scale actually flakes off the part using our ice machine cleaner. And the reason why is that we're only attacking the bonds that hold the scale to the part. So we're able to make products safer, greener, use much, much less chemicals, and they're faster acting because we have a lot less scale to dissolve. So when we look at other products, for example, our grill and griddle cleaner, our floor cleaner, and our condenser coil cleaner, we use the same principles of physical properties as we did with the ice machine cleaner. Whereas most traditional chemicals are designed to dissolve, agglomerate, and remove fats, oils, dirt, grease, and so on from the fryer or floor or so on. Well, we're using that alkaline property, the alkaline physical property of water, to mix with the oils and fats to actually clean and turn that into a soap. If we had a chance to talk to our great-great-grandparents, for example, they would tell you that they made their own soap, and they would take a highly alkaline water, mix it with an animal fat or a vegetable fat, heat it up or turn it up or spin or mix it up, and it would turn into what they would call a lye soap, which was excellent for laundry, for any cleaning around the house. Scientific term for that is called saponification, where we take a fat and highly alkaline solution and turn it into a soap. Well, that's exactly what the grill and griddle's doing, the floor cleaner and the coil cleaner. So we're able to actually take the fats, oil, and greases and turn them into a product to eliminate chemicals, make our products greener, safer, and faster acting. Now, if there's any questions or comments, I'll be more than happy to answer them if I can.
Yeah, Phil, we've got some questions here. One of the questions is, you're talking about how safe this product is, and Jim and myself, we looked at the labels on the product, and man, there's a lot of warnings on there. Can you address the safety issue more? I mean, do they need to wear goggles, gloves, aprons?
And Pretty can help answer this question, but we're somewhat limited to what the OSHA and SDS sheets the requirements are. People don't understand. For example, water, as I mentioned before, coming out of our ID media. It goes from neutral of a pH 7 to a pH of 11 or up to 13. In chemistry, there's something called pKa and pKb, but what the MSDS sheets and what OSHA looks at is strictly the final pH. Even though that our pH, for example, of 13 is not caustic, it has a very low pKb, we're required to have those warning labels on it because people really don't understand electrochemistry yet, and it's a big education process, not just for us to educate OSHA and the people who write the MSDS sheets. It's somewhat of a challenge for us. We have to comply based on current regulations, but the answer to your question is, and I think Aaron will talk to this specifically, that gloves are probably not required, but just as good manufacturing practices would suggest that they should be, just because there's some people that have some issues to, could be, some sort of, I don't know, allergic. I don't know if that's a good word or not to some of these small amounts of chemicals that are in it. But they're certainly far less dangerous, far easier to use, far more safe than what competitive products would be. Sorry for that long answer.
Okay. No problem. Jim's also got a question here for you. Go ahead, Jim.
We live in an area with extremely hard water. So there's a lot of lime buildup in faucets and everything. How does it react to a lime issue?
Yes. You're going to find that the ice machine cleaner, and again, Aaron will be good to speak to it because he runs into it all the time as well. But it should be very, very effective at removing that scale. One of the things that Randy will probably talk to you about is that we have what we call a heavy-duty ice machine cleaner, which is designed for ice machines or other high scale that have not been cleaned in a long time, and that has a lot of buildup to be able to take that buildup off very quickly and then go to a maintenance program using our regular ice machine cleaner. So one of the things that I realized when we were developing this product is there are certain parts of the country, the Midwest being one of them, that have very hard water, and that if an ice machine or other type of parts that get scaled have not been maintained on a regular basis, our regular ice machine cleaner is probably not going to be that effective on it, or it's going to take much longer to clean. So we developed this heavy-duty ice machine cleaner just for those cases. So we have a backup for that, but once a part or ice machine cleaner has been cleaned, then it goes on a regular maintenance program. Then the amount of hardness in the water should not matter. The regular ice machine cleaner should take care of it.
Okay, we have a question from Steve Walden.
I have just a follow-up to that. We also have a lot of people here with wells, water. Communities provide a community well, and that water is very inconsistent. My time on the street where if we put a coffee machine in, we had to put a lot of different kinds of equipment on the back of it to keep it from scaling and all that. Does this work in all types of water? And then my other question is, this is this new technology. How much information has been provided to the health department when they come in and look? Because they look at that stuff now, and they see that there's a lot of stuff on that label there, and they're going to question this. If we tell them that it's a much safer product to use, what would be our response to that? The guy calls up and says, "Hey, the health department says I can't use it because there's too much junk in it."
Right.
Well, I'm not familiar. Maybe Aaron would be, but what I'm familiar with the health department is looking at things like that might be what we call a sanitizer or a disinfectant. That would be primarily what they're interested in. Cleaning chemicals and things like that, I don't think they regulate, but I could be wrong. Your question about hard water, you certainly work with hard water. Hard water has a lot more mineral content as well. So again, if you're on a regular maintenance program with a particular, and I think Randy could talk to this about being used in a coffee machine or something like that as well. If it's on a regular maintenance program, our ice machine cleaner would be very effective. If it hadn't been serviced in a while, the heavy-duty ice machine cleaner would probably be preferred to use first to remove the heavy scale buildup, and then as the regular ice machine cleaner being used on a maintenance program. But keep that question to you, because I think Randy or Aaron, who have more experience, and especially Aaron, because he runs a business out of Atlanta that deals with the health department all the time, so he might be good at answering that as well. Unless you want to chime in right now, Aaron.
Yeah, well, we've dealt with the water scale coming out of well water here locally, and it works very well at breaking it loose and being able to get it out. My wife actually uses it in the tub and toilet and everything else to get our scale off of we're on a well as well. So we've used it in different places to get that water scale and off of stuff. But yes, the heavy duty version is a much more aggressive product. This one is just far safer to use because we're not talking about a 75% phosphoric acid solution that is DOT regulated, and you have to properly dilute. So it's just for the usability in comparison to everything else on the market, this is a much safer way to go.
Yeah, just to add to that, what Aaron said is that the typical ice machine cleaner is that he said is 75% acid. We use 1.5%. So you can see the dramatic decrease in the amount of chemicals that we use. Again, it's all about the water. That 1.5% is in there strictly to speed up the ability to dissolve that scale at that interface very rapidly. So that gives you an idea of the difference in chemical concentration between ours and someone else's.
Oh, that's big.
All right, this is John. I've got two questions for you. The first question is, do you have to, after you're done with the cleaning process, and I'll use the boil out as an example, once you're done with that process, do you need to go back and neutralize? I know years past, after boiling out a fryer, you'd have to do a vinegar rinse to neutralize any chemical left in that fryer. Is there anything like that would have to happen?
No, strictly because what we're doing there, again, we're making a soap, and so basically that soap is well, we're changing the fats, oils, and greases into that soap. That soap gets all washed out. You are rinsing it right after you do a boil out. You are rinsing. After that rinse, that's all you should have to do.
Okay. And then my last question is, each box of chemicals or case of chemicals, are they going to have, or do they have a material safety data sheet?
Yes, we can. You can pull our safety MS, or they're now called SDS, but you can pull them off our website at ID Clean Ice, or you can request them from us. I don't think every single case will have one because that's. I don't think. I think you will have to either pull them off the website, or you'll have to request them and have us mail them to you. But they're not going to be in every box.
Health departments are asking now to see your data safety material book, or whatever you want to call it, so they're required to have a book on site with chemicals that are in-house. So Jim has a question for you.
Yeah, we called on an account yesterday that's a small chain of restaurants out of Ohio, and I'm good friends with the owner, but he puts a chemical in his fryer to clean his oil.
He actually adds the powder to the oil
to clean it, and then he filters it. What is the price? How do we overcome that competitive? When he uses the chemical.
Yeah. So what he's doing, he's actually using what we call diatomaceous earth or some other filtering out the solids of the oil, and some of oil, as in the fryer, there's a certain life to that oil. and so you can recycle it. There are companies that will go and filter through either diatomaceous earth or activated carbon to be able to remove the particulates that the food particles that are left in there, as well as some of the oils that just precipitate out. I don't know if we're really competing there, because we're looking at more on an area where the oils have actually been spent at that point, where you can actually filter some of the oils out and recycle them a number of times, probably 3 or 4. At that point, you actually have to change the oil out and put new oil in, and really that's where we are going to be the greatest strength. Now, what he could do, if he wants to, after he filters that oil, he may want to clean the fryer compartment. Then he could use our material and then put that older oil back. But I'm not sure if they do that or not.
Yeah, you said the powder, when adding the powder, and I could get this wrong, but it was extending the pH level of his oil. I guess health departments now are actually have a dip that they're dipping in the oil and checking pH levels. And I guess it's actually started in Germany and it's making its way to the U.S.
Yeah, and it makes sense because not every area has a place where they can recycle the oil, and so being able to filter it yourself and extend the life of that oil makes a lot of sense. And so when you add things like diatomaceous earth, which is an alkaline product, or activated carbon, which is an alkaline product, it will boost the pH back to where the health department is probably looking for that pH range. But again, you can only do that a certain number of times before the oil no longer will pH will bounce back to an alkaline pH.
Okay, Phil, I got a question that just came in from one of our reps up in Green Bay, and his question is, are there any DOT regulations on transporting samples of these products?
No, we ship, for samples, we ship via UPS all the time, and have been for, over 2 years.
Okay. Thank you.
Okay, so John, if all of those questions in the office are complete, we don't have anyone remotely that has questions, but I'd like to touch on 2 little things about the SDS sheets. Everybody will have access to download our SDS sheets online, and so any of your clients, you'll be able to direct them to a location where they can just download the SDS sheets. And
okay.
Then the first question that came up was on the safety. As Phil Adams pointed out, we are required to follow the regulations, according to OSHA. However, on our ice machine cleaner, we did take a additional step to do testing on acute dermal toxicity testing to show that our product is quite safe on skin.